Okay, we're going to look at some of your sample problems from section 2.3, the function information. All right, so the base idea of a function is that no x is repeated. For every x value that you input to the equation, you come out with a unique value of y. In other words, no x can be repeated. So on this first one, we just have a list of points. And so we're just looking for the x value to see if there's a repeated x value in that one. So there is not, so we're going to say yes, that relation is a function. Okay, the second one, same idea. We have just a list of points. Now, this isn't normally how we'll see our problems. We'll have an equation or we're graphing, but this is just to get us warmed up, looking at just a small set of points. So in this one, we have a 3 with 2, a 4 with 2, and a 2 with 1. Now, you might notice that the y was repeated, but the x value, 3, 4, 2, not repeated. So yes, that's a function. All right, again, with the t-table view of it, so we're looking down the list, this x, this x, this x, the y is repeated a lot, but the x is not, so yes again, all those are yeses. Number 4, determine if this is a function, and so this is a line. Linear equations are always functions. I guess the exception to the rule would say is the actual vertical line. If you had a straight up and down x equals vertical line, it would not be a function, but all other non-vertical lines are functions. And also the vertical line test, if you can draw a vertical line and only hit it one time in any one place on the graph, then that also says it's a function. So yes. And for linear equations, the idea of domain is where does the graph go left to right? Or what could you put in for x in a linear equation? That's everything. Negative infinity to positive infinity. And for the range, the up and down, the vertical values, the y outputs would be the same here. I call this friendly no because everything's okay. Everything's a yes on this, and everything open. There's no tricks or turns on it. All right, number 5. Okay, here to see it's not a function. The vertical line, you see how it hit it in 2 places. So one a 4, the value up here and down here. There's 2 y values corresponding to 1 x value. And so that is in direct contradiction to the definition of a function. So the vertical line test hits it in 2 places. Most places you can draw. Of course, over here there's nothing, but any place where the graph is, you're going to hit it twice. So nope, not a function. Give the domain and the range. So the domain is the furthest x value to the left is -4, and then it goes to positive infinity this way. It touches or includes the point at -4, so we use a bracket, and then it goes to positive infinity this way. The range, this is going up. In the screen, you know, right here, it looks like maybe that's as high as it goes, but that's why there's arrows there. It keeps getting a little higher all the way out to infinity. This keeps getting a little lower. So more than what we can just see in the grid we've got here, but the range is negative infinity to positive infinity is theoretically how low and high this graph could go for y values. Now we have an equation to decide this from without a picture or a set of points, so more theoretical. So this is what could you plug in for x and what could you get for y. And we know this to be the line and that anything goes. You can plug in anything for x and the y values come out to be anything for y, positive and negative infinity on that. And then of course a line is a function. And we could graph it. Did it ask us to graph it? No, did not ask. Okay, number 7. Now we're getting to one that's not just anything goes. If we were making a t-table, this is one way to figure out your domain and range, is just try to put in values for x and y, try and see what is permittable that gives real out. So we can put 0. That's usually your first thought, right? If you plug in x as 0, 5 times 0 plus 3, square root of 3. It's not our favorite number maybe to graph, but it is real. Put in 5 times 1 plus 3, yeah. Again, not my favorite number to graph, but it is real, so it counts. And 2 and 3 and so on. It looks like, you know, that's going to be fine. Also, I could plug in fractions. I could plug half. You can check that out. You can do your table of values on your graphing calculator if you want to check it that way. And it looks like positive numbers are going to be okay. Let's try some negatives, like -1, for example. 5 times negative 1 plus 3 would be negative 2. Square root of negative 2 is going to give you an error reading on your calculator. If you try to graph it, you cannot graph the imaginary number there. So negative 1 we'd say is not in the domain. But where exactly did that happen? Was it a fractional amount somewhere? The only way to figure it out absolutely is you ask the question, what keeps the stuff under the radical, this 5x plus 3 in this case, positive or greater than or equal to 0? And that's really where the domain is. So to solve that, you throw the 3 across the line, and then divide by 5. And so this changeover happened at exactly negative 3/5. That's the first number you can plug in and get a real output for y. So the first value is negative 3/5. That's our domain. And then anything larger than that. And we can include negative 3/5, so put a bracket. Oh, and it is a function. This is our graph that I guess it starts back here. It's our arc graph, our square root function, and those are allowed as functions. There's no repeats vertically, so that's a big yes for that. What about this range? What was the first value that I can get for y when this is graphed? And you may just want to use your graphing calculator or the app on your cell phone to kind of check this yourself. But the lowest y value is at 0. And also from our t-table perspective, when we plugged in negative 3/5, if we were plugging that in, we put it in for x, the output is the square root of 0, which is 0. That's the lowest y value we get. Now, what we're going to learn later in the chapter is sometimes there's like a plus 1 on the end, and then it takes what you got there, 0, and then adds 1 to it, so it's 1 higher. So it could be that the first value you get when you plug that in is changed if there's an addition or subtraction on the end, but there is not here. So it's just simply that radical. When you plug that in, you get 0. So that's the first number you get for y, and then larger. Also, if you can graph it, you can look at it in domain and range, and that's helpful too. All right, then we switch gears on number using the notation. So fx, we've got a defined function, and it says find of 0. So this, I'll plug this in for x. Whatever you have in this parenthesis gets input to the x. So it's negative 5 times plus 6, and then that comes out to just be a 6. Answer of 6 there. Okay, number 9. All right, so this time it tells us to plug in x plus 3. We prefer just plugging in a number, but it wants to plug in some algebra or an algebraic expression. So we plug that in for x. Whatever it says goes into the x in the function. So we have, let me get it up here, negative 5 times x plus 3 plus 6. Then distributing is negative 5x minus 15 plus 6. Negative 5x minus 15 plus 6 is minus 9. So our answer is negative 5x minus 9. Rearrange it a little bit. Okay, next one. This time we have a view of a graph. Instead of giving us the equation, notice there's no equation given in number 10. We have a picture. And remember, a picture is, or graphing is a picture of the equation. It's a picture of the solutions. So we can do that. So f of negative 1, remember this means plug that in for the x value. So look for x is negative 1. Okay, the x-axis, here's negative 1. At x is negative 1, what is the output? So that means what is y? So it's down 2 places. At x is negative 1, we have a y value of negative 2. You could check it out on this graph. Back 1 hits the graph at negative 2. So the y output, as if we would have put it in the equation, if we had the equation for this line, and we could maybe figure that out, if we had the equation for this line and we plugged in x is negative 1, we would get algebraically 2, and that's why it would be on the picture that way. Okay, number 11 is more of the same. Under 11, just blunt them. Okay, all of these are going to be x values, so we look over here at the graph, go to x is negative 3. Okay, there's x is negative at 3. That y value, it's not up nor down, so it's at 0. Next one, f0, let's go to x is 0. Here is, x-axis, right? Here's x is 0, And then where is the y output? It's up here at 6. Next, f of 5, that means go over to x is 5. Here's x is 5. Where does it hit the graph? That's up 4 places. So the y value is 4. So again, this is the x value. You're looking for the y coordinate that goes with that. So at x is 6, the y coordinate is up 6 places. All right, switching gears again, number 12. Number 12 asks us to solve this equation for y and then use the f of x notation. So make it in y equals form. So instead of x plus 4y equals 9, we'll throw the x across the line and have 4y equals negative x plus 9. Then dividing by 4. So we're getting it y equals mx plus b form, you might think of it as. So that's what goes here instead of y equals. We know y and f of x mean the same thing, so we type that in. Then on b part it says find f of 6. So that means now that you've got it solved for y equals, like the equations we had earlier, plug in x is 6. So we plug a 6 in there, it'd be negative 1/4 times 6 plus 9/4. You can just type that on your calculator, which would be, I'll do it by hand, negative 6/4 plus 9/4 would be what, 3/4 for our final answer. But feel free to use your calculator. I feel like I have to check my answer key on that since I did fractions. So number 12, yeah, 3/4. Okay, number 13. Oh, we good again. Practice that again. So 6x minus 3y equals 2. Solve y by throwing the 6x across the line. Will be negative 3y equals negative 6 plus 2. Divide both sides by negative 3. And y equals negative 6 divided by negative is positive x, and 2 over negative 3, negative 2/3. So that's what we put in. F of x equals 2x minus 2/3. Then find f of 3. That means put the 3 in for that x. So it's 2 times 3 minus 2/3, which would be 6 minus 2/3. Again, feel free just to put that right in your calculator. If you were getting a like denominator, it would be 18/3 minus 2/3, which is 16/3. We like fraction answers. They're more exact. You'll notice that the program is not set to intake decimals. Like on this case, it would be a repeating decimal, so you'd have to round. So it's just better to keep it as an integer. If it comes out even, that's an integer, or as a fraction to be on the safe side. To more exact, I should say. Okay, then number 14, shifting gears again. This one is about increasing, decreasing, and constant. So that has to do with the slope of each section. We got 3 sections of the graph. If I lay my pencil there, you can see this is a negative slope. So that's the decreasing part of the function. This is a positive slope, so that's the increasing, and this is the constant part, the 0 slope. So we want to go through and list each part of that. It does say open intervals. It's always defined as the open intervals, so that means just use a parenthesis instead of a bracket. Don't include the endpoints. So we want to list these in terms of the x-axis. So we've got to choose, either x or y perspective, and this is based on the x, the domain values, where it is each of these. So let's do, I think it asks you increasing first. Okay, so the function is increasing. So where is it increasing? This is the section that's increasing. It increases from at negative 3 to positive 2. So we'll say negative 3 to positive 2. That would be the open interval that has a positive slope. And again, I did it from the x values where this is positive. Then for the decreasing, I think that's next. Yeah, decreasing, that's this section. This goes all to negative infinity, and then it stops at negative 3. So we would say negative infinity up to negative 3. That's the negative slope, or the decreasing part. Then lastly, it asks you about constant. Constant is the flat line, or the 0 slope, where it's just flat. So that starts at x is, made a mess here, at 2. X is at 2, and then all the way to positive infinity. So 2 to positive infinity for that.